Okay, so in this video, I'm going to go through the 2020 A-Level Maths Paper 3, the mechanics section. So in the previous video, we were looking at the statistics section. These are going to be my written solutions for the mechanics section. So let's go to question 1. Okay, nice question to start us off here. Got a rough plane is inclined to the horizontal at an angle alpha where tan alpha is 3/4. Got a brick P of mass m is placed on the plane, and we've got the coefficient of friction between P and the plane is mu. Brick P is in equilibrium and on the point of sliding down the plane. Brick P is modelled as a particle. Using the model, find in terms of m and g the magnitude of the reaction between the plane and the brick, and then show that mu is 3/4, and we'll keep going onwards from there. Okay, so diagram. My planes always look a bit odd, but we draw a little diagram. Now, it's going to be on the point of sliding down the plane, which means friction will act upwards. Friction we also know will be mu r. We're going to need that for part B in a moment. Now, our weight of the box was mg, and we're going to need our normal reaction force. Right, so first thing we're going to do, break that down into component parts. Now, this angle and this angle at the bottom here will be the same. Because they're at an angle alpha, this also will be an angle alpha using our properties of angles. So the opposite will be mg sine alpha, and the one that's adjacent to it will be mg cos alpha using a little bit of trigonometry. Now, so if we resolve upwards downwards to the plane, i.e. resolving perpendicular to the plane, and we're going to get that r will be equal to mg cosine alpha, which is useful to us because we know that tan alpha is 3/4. So quick diagram will get us what this side will be 5. Now we want cosine alpha, which will be 4/5. So this is going to be 4/5 mg. Okay, nice and simple for 2 marks. Part B, show that mu is equal to 3/4. Okay, so if we want to get mu is equal to 3/4, we need to resolve parallel to the plane. So for the resolve parallel to the plane, then we're going to get the frictional force, i.e. that mu times an overreaction will be equal to the mg sine alpha. And then we know what r is already, so it's mu times 4/5 mg. That's got to be equal to the right hand side, which is going to be mg times by sine of alpha. Now sine alpha we know is 3/5, so it's literally mu of 5/4 multiplied by 3/5. So that 5 will cancel and leaving you with 3/4 as required. Okay. Right. Moving on to the next bit. For parts C and D, you are not required to do any further calculations. Okay. So brick P is now removed from the plane, and a much heavier brick Q is placed on the plane. The coefficient of friction between Q and the plane is also 3/4. Explain briefly why brick Q will remain at rest on the plane. So, in general, if you thought about it a little bit, we know that the frictional force has got to be equal to mu times an all reaction. Now, if you write in what we know, you get mu mg cosine alpha, won't you? Now, mg is literally just the weight, so this is just w times mu cos alpha. So this is the frictional force is k times w, i.e. that the frictional force is proportional to the weight. So we can say that friction is proportional to the weight as the masses will cancel out in effect. Alright. Part D. Describe the motion of brick Q, given a reason for your answer. So, brick Q, it's got no resultant force whatsoever. It's got a constant speed. So it'll slide down the plane. Makes sense. Right. Moving on to the next question. Give me so much paper for this first question, jeez. Right, question 2. We've got a particle P moves with acceleration of 4i minus 5j meters per second squared. And at time t equals 0, we've got P is moving with a velocity minus 2i plus 2j. Okay, so I've got my acceleration, I've got my velocity. I can actually jump straight into this question, because all I need to do for the first part of this question is to integrate this thing, because we're looking for the velocity at time t equals 2. So you've got two choices. You can either integrate it, which is my first thought, or we can use a little bit of our further kinematics knowledge. So you've got two ways you can do this. You can either say, well, V is U plus AT. It makes sense to us, we know that from our SUVA stuff. Or we can say, well, V is the integral of the acceleration vector in respect to time. So you get 4t in the I minus 5t in the j plus some constant. And then when you stick in V0, you're going to get that c is minus 2i plus 2j, such that v as a function of t is 4t in the I minus 5t in the j minus 2 in the I plus 2 in the j, such that v2 will give you 6 in the I minus 8 in the j. Now, if you didn't want to do it that way around, you could certainly go to this formula here, and you could plug it in and try it. You get minus 2 plus so 4 minus 5 times by 2. So the minus 2 plus 8, and then you've got 2 minus 2 minus 10, which is going to give you 2 minus 10, rather, that should be. So it's going to give you minus 2 plus 8 will give you a positive 6, and 2 minus 10 will give you minus 8, i.e. giving you what I got using the integration. So you can do it either way. You're not really penalised if you use one instead of the other. But like I say, you got many ways you can do that first bit. For the second bit of the question, we're looking for the value of t, given the position vector of A is lambda I minus 4.5j. Now, you can do this in many various ways. The way I want to do this, though, is that I know the distance r is going to be a ut plus a half at squared. So I'm going to go lambda minus 4.5. Then I'm going to put that equal to minus 2t plus a half of 4 minus 5t squared. So if we look at the j component, we're going to get that minus 4.5 has got to be equal to 2t minus 5 halves t squared, which is going to give you 5 over 2t squared minus 2t minus 4.5. So I could again multiply through by 2 if I wanted to. So we get 5t squared minus 4t minus 9. And do that way. Which I think will give you t as 1.8, because you can't have negative time being t is minus 1, can you? So t 1.8 as t has got to be positive. Which it does tell you in the question that t must be bigger than 0, so yeah. And then the last bit is to find the value of lambda. Well, to find the value of lambda, I'm just going to look at the I component. If we look at the I component, I'm going to get that lambda is going to be minus 2t plus 2t squared. And then if I stick in that t is 1.8 from the first bit I did before, I get lambda. So that'll be 2.88, I think. Yeah, 2.88. Cool. So not a bad little further kinematics question there, but makes you think a little bit, which is good. Question 3. What have we got for question 3? Oh, we've got another one similar to the one that we just did. Slightly can't think of anything else. So at the instant when t equals 0, the velocity of p is 36i. That's the initial condition. And it's so important. I'm going to highlight it. We're given that t is bigger than 0 and we've got an acceleration vector. Okay. Now, it also does say, down here for this next bit, when p is moving in a direction perpendicular to I. Now, if it's moving perpendicular to I, that means that the I component will be equal to 0. That's one of the key bits for this question. And not many people got that when this question was done, and many people looked at it. So what I'm going to do is integrate this vector to get v. That's what I'm going to do. So v is the integral of 1 minus 4t I plus 3 minus t squared j. So yeah, v is t minus 2t squared in the I plus 3t minus a third t cubed j plus some constant c. Now, when we know v is t is 0, we get the velocity is 36i. So we get that 36 in the I is 0 plus c. So c must be 36i then. So I can add that into here, so I get that the velocity vector evaluated when t is 4 is going to give you, I think it's 8i minus 28 over 3j. I have no idea, I've not done these questions before, so I'm just going at them with a little bit of mathematics in my head. At time, let me do part B rather. Part B, we know that I is going to be 0, so from here we know that t minus 2t squared is going to be equal to 0. That factorizes quite neatly, doesn't it, to t plus 4 And then, was it 2t minus 9? That'll factorise nicely. So you get that t is minus 4 or 4.5. T is 4.5 is useful. As t is positive, that means that t must be 4.5. Part 2. We've got... ooh, nasty. We want to find the value of t at the instant when the speed of q is 5 meters per second. Okay, so we're given this thing. We know that mod v is equal to 5, don't we? So we need to get v. Now, the only way we can get v is differentiating this. So we're going to get 2t minus 1 and 3. So we know that means that 2t minus 1 squared plus 9 rooted has got to be equal to 5. Standard vector stuff. Now, if we square both sides, and that gives us 25, take the 9 away, that gives you 16. That means I can take the root fairly quickly. So we can get that we get plus minus 4. So we can get that either that t is 2.5 or minus 3 over 2. So I need to take the 2.5 because we know that t must be bigger than 0. Right, there you go. Question 3 done. What's next, people? What's next? Question number 4. Scroll down to question 4. Oh, it's a moment's question. Right, we've got a ladder AB. It has mass M and length 6A. The end A of the ladder is on rough horizontal ground. The ladder rests against a fixed smooth horizontal rail at point C. The point C is at a vertical height 4A above the ground. The vertical plane containing AB is perpendicular to the rail. The ladder is inclined to the horizontal at an angle alpha, where sine alpha is 4/5, as shown in figure 1. The coefficient of friction between the ladder and the ground is mu. The ladder rests in limited equilibrium rather. The ladder is modeled as a uniform rod. Show that the magnitude of the force exerted on the ladder by the rail at C is 9 mg over 25, and hence, or otherwise, find the value of mu. Okay, this is not so bad, because, well, I can do it 2 ways, really, with these questions. There are many methods in the mark scheme for this. I'm going to just go and jump in the method I usually do with these. Is, first of all, to break this into parts and break the question down. So I'm going to have the weight of the mass at M, so this would be mg. I've got my frictional force, I've got my normal reaction from the floor. I've also got the normal reaction at C to deal with, which I can break down into components. So I'd end up with n cos of the angle alpha and sine alpha. This can be broken apart as well into mg sine alpha, mg cos alpha. We're also given that that sine of alpha was 4/5. So that means that we can get cos alpha is 3/5, and tan alpha I can do sine divided by cos, and that will give us 4/3. To the 5's cancel. Right, so I've got that bit. I've got everything I need. I've got my distance because I know this is going to be 3a away. And this big distance from A to C, which is in a different coloured pen, this will be 4A over sine alpha. Hopefully you can see where that's come from. If not, then ask me in the comments down below. Right. So, the first thing I'm going to do is to take moments about the point A. So I'm going to get n times 4A over sine alpha is going to be equal to mg cos alpha times by 3A. Right. So I'm going to get 4n divided by 4 fifths. It's got to be equal to 3mg times 3 fifths. So I get 5n is 9mg over 5. So I get m is 9mg over 25 as required. Nice and easy. Right, I'm going to keep the diagram because I'm going to need it for the next bit. I'm also going to end up resolving horizontally and vertically. If I resolve horizontally, I've got my frictional force, but I also need the component of n, which will be n sine alpha. And then I also need to look at resolving up and down vertically. I get r plus n cos alpha will be equal to mg. So r plus 9mg over 25 times 3 fifths has got to be equal to the mass times gravity. So I can get the value of r out. It's not nice, 98 mg over 125. I think I get on my calculator. But we also know that friction is mu times an R reaction. So mu is F divided by R, which is just 36 divided by 98, which is 18 over 49. Again, there are many ways to do this question. I can do that in a couple of lines. You might not be able to do it as quick as me, but, you know, it's up to you how you want to go about these questions. Right, last bit. Question 5 of the mechanics section. It's a projectiles question. They always are. They're never going to give you a question where it's not going to be a projectiles as on these mechanics questions papers. So, we've got a small ball projected with speed mu meters per second from a point O on the top of a vertical cliff. They always pick cliffs or something, don't they? The point O is 25 meters vertically above the point N, which is on horizontal ground. The ball is projected at an angle of 45 degrees above the horizontal. The ball hits the ground at the point A, where A to N is 100 meters, as shown in the figure 2. The motion of the ball is modelled as that of a particle moving freely under gravity. Using this model, show that U is 28 and find the greatest height of the ball above the horizontal ground N to A. Now, the way I like to do these questions is dependent on the mood I'm in. I can do them in two ways. I can do them horizontally, then vertically, or I can be mean and just draw a table. So I'm going to draw a table because I like drawing tables. So X, Y, I've got my suvat, which I'm going to write down. So, distance in the X, 100. The U is going to be the component of this, which is U cos 45, being careful. Now, the final speed will also be U cos 45. The acceleration, however, will be 0, and the time is just the time I don't know. And the time over here, I don't know what the time is. However, I know the acceleration in the y direction will be minus g. I don't have a final speed in the y direction. I have a initial speed of u sine 45, breaking this down into component parts. And the distance will be minus 25 because I'm taking upwards as positive. I should write that down. I'll just write that down there. Okay, so I've got my table. Now, I know that the speed is the distance divided by the time. So u cos 45, 100 over t, so t is 100 over u cos 45. Alright, so I've got a value of t. Now, I know that s is equal to ut plus a half a t squared. That's the formula I'm going to use, and that's what I'm going to sub in. So I've got minus 25 has got to be the component, which is u sine 45t minus a half gt squared. So, minus 25 is going to be u sine 45 times by 100 over u cos 45 for the value of t. Subbing that in. Half g of u cos 45 squared. So I'm going to get minus 25. Use cancel, sine over cos gives you 10. 45 minus half g of 10,000 over u squared cos squared 45. So u squared is minus 1/2 g of 1,000, or 10,000 rather, over cos squared 45 of minus 25 minus 10 45. Now, if you stick that lot in your calculator and take the root, you do indeed get 28, because you get the root of 784, which is 28. Not nice, but that's what it gives you. Right. Moving on. Find the greatest height of the ball above the horizontal ground. Enter A. Okay, so the highest point above the ground is Subat again. No chances for guessing what the Subat's going to be. Now, I don't know the time, but I know everything else. I know what U is. U is 28. Now, the S value, I'm just going to call H because I don't know what the distance is. I know what my V is going to be. And I know my acceleration is minus g. So, it's going to be 28 sine 45 squared at minus 2gh. So get 2gh is equal to 392. H is 392 over 2g, which is 20. However, the greatest height will be 20 plus the initial height it already is, i.e. 45. So, in a refinement to the model of the motion of the ball from O to A, the effect of air resistance is included. This refinement model is used to find a new value of U. How would this new value of U compare with 28? So, it's a bigger speed is needed for the same distance. In fact, let's write this down. So, it's the last bit I need to do. So, a bigger speed is needed for the same distance. So U will be bigger than 28 as resistance reduces overall distance. Part D. State one further refinement to the model that would make the model more realistic. So the spin of the ball, size, I think, is also fine. You could also write like a more accurate value of G. Instead of using 9.8 all the time. That's also fine as well. Right. I believe that is the end of the paper. Total for mechanics is 50 marks. Might give you 50 marks there, easy, isn't it? Right. So, up to the top again. Thanks very much for watching this little video. Like I say, that is me just going through my solutions. If you got any questions about any solutions that I've done through, then please, leave me a comment. I'll try and get back to you as quick as I possibly can. Like I say, these are my written solutions. I've got better solutions I can send you if you can't read those at all. But like I say, it's pretty straightforward. Alright. Thank you very much for watching. I'll see you in the next one.